Hello, my name is Pius. Now I'm from group 3. Now I want to show you the embedded microcontroller lab E2 part 1. This is the first question of first circuit of the of the part 1. First we do the first part. There is you can see is VDD to the minus VF, then minus the voltage of the resistor and to the transistor and to the ground. So from the calculation we can get is 177.78 ohms. To get the RB, then we can see the second part is here. That is from port to the RB and go to a transistor and go to the ground. Then before we calculate RB, we need to get IB first. That is the current of the RB. Then how to get the IB is we can use the formula that is 10 times ID over HFE. That is 9 times 10 negative 3 over 200 times 10. So we can get 4.5 times 10 negative 4 ampere. Then from here is VOH minus IB times RB minus VBE equal to 0. So we can get the RB is 4,888.89 ohms. This is the coding we built. Then here we use the PTOR to light out the LED. PTOR is the toggle, so the bit will change to 0, then change to 1, then change to 0, then change to 1 repeatedly. Then let's play. From here you can see our LED will blink because the bit is changing. Okay, now we're doing the question 2 of the part 1. Then from the part 1, let's see here, there is VDD minus VC minus VF minus IDRL, the voltage of the RL. So it's 3.3 minus 0 minus 1.7 minus, then minus 9 times negative 3 RL equal to 0. From the calculation, we can get the RL, that is 177.78 ohms. For the LB, first we need to get the IB first, the current of the RB, that is 10 times ID over HFE. So we can get so it's 10 times 9 times negative 3 over 90, then equal to 1 times 10 negative 3. Then how to get the RL? First is VDD minus VBE minus IB times RB, get the voltage of the RB, then minus VOL equal to 0. Then is 3.3 minus 0 minus 1.1 times negative 3 RB minus 0.5 equal to 0. Then from the calculation we can get RB is 2.8 kilo ohm. Now this is the coding of the question 2. It's same with the question 1. We use the GPIOA PTOR. Okay, let us start. So you can see here my LED still is like the question 1, still blinking because I use PTOR.
Hello everyone, my name is Muhammad Azim from Lab Group 3, and in part 1, my partner Pius did a great job in explaining that to you, and now it's my turn to explain part 2 to you guys, so here we go.
Right, let's get into the codings for part 2. We will include the normal headers, such as include derivative.h and include stdio.h. Next, we will define the 3 main output ports, and we will be using port A, only port A, to prevent any complexity. Port A pin 2 will be connected to the serial input. Port A pin 12 will be connected to the shift register, and port A pin 13 will be connected to the store register. Meanwhile, we'll be using 3 voids. One is to initialize the bar graph. Another is to look at the levels of the bar graph, and lastly is the delay. Now we shall take a look at the first void, which is to initialize the bar graph shape. First and foremost, we gotta enable that we have to enable clock signals to be transferred to our main port, which is port A, using this one line of code right here. Next, we have to make port A pins 2 and 12 and 13, those output ports, to be simple port pins with a high drive strength. And next, for all of these outputs to work, we need to enable and activate these port outputs by using these sets of codes, which is GPIOA_PDDR. Now, in the early stages, my partner and I, we left out these sets of codes, which proved to be very vital to ensure that all LEDs does not light up before the program is being executed and before the next line of for loops occur. Now in the bar graph void, we will start by clearing the serial input to make sure that it is 0 initially. Then we will start the first for loop, which is to clear the register and add 0 to that serial register. Then, outside of that for loop, we will now change the codes to GPIOA_PSOR for the serial input to set the main input to 1. Before beginning the second for loop, which is dependent towards level as in the number of LEDs that will light up. Now, we have been advised to use PCOR ahead of PSOR as it will help to provide positive transmission and reduce processing speed. And outside those two for loops in the end, we will have GPIOA, PSOR and PCOR store underscore mask to store the values of 0 and 1 into the software's memory. In the delay void, it's just a simple coding right here. We'll initialize D count to illustrate as delay count, and we have set the delay count to be 500,000, which is respectable enough for us to see the results. We have also implemented ASM no so that no operation will be missed from this code. Now lastly, in the main function, we will initialize the bar graph and we will have two for loops within an infinite for loop. The infinite for loop is to allow the program to run continuously unless terminated or paused. In the first for loop, inside the infinite for loop, we will set the LVL to be 0 and less than or equals to 8. This way, when the program is executed, no LEDs will light up, and when the for loop runs, one LED will light up at a time until all 8 will be light up, and then we will have a delay. And in the second loop, we will start LVL with 8, and LVL will be set to be more than 0. This is to make sure that all LEDs are light up and will turn off one by one until none of it will light up anymore, and we will delay it again until the process will continue unless terminated or paused. Now outside those two for loops, we have set LVL to be 0. It is to maintain that the next round of infinite for loop, we will make sure that no LEDs will light up. So this is how our circuit will look like once we connected and executed the program to the output port right here. As you can see, we will start with 0. We'll start 0 and the LED will light up one by one, delay, and it will turn off one by one, stop, and delay again. Thank you all for watching this video and hope to see you again soon.